All right, we're going to talk about measures of position. So far, we've talked about measures of central tendency. We've talked about measures of variation, how much they're spread out. And now we're going to talk about how you compare them by position. Okay. A lot of this, a good portion of this one will be simple for you, I think. Okay. So first, we're going to find the first, second, and third quartiles. It's like doing box plots. Remember doing box and whisker plots back in elementary school? Basically the same thing there. And then they'll find the interquartile range of the data using a box and whisker plot. We'll also talk about fractiles and percentiles. You know, a lot of people get confused about percentage and percentiles. There's a slight difference there. Make sure we understand that difference today. And then, of course, we're going to determine z-scores. Z-scores are what tell us basically how many standard deviations away from the mean our data is. Okay, so it allows us to put our data on that empirical scale that we learned about yesterday. Okay, so the z-score tells us a lot about the data initially. Okay, fractiles are numbers or the partition or divided of an ordered set. Okay, the one we're going to deal with the most is quartiles. And quartiles, where we divide it into exactly 4 equal parts. The first quartile is about a quarter of the way up. The second quartile is about halfway, and the third quarter would be 3/4 or 75% of the way up the data. Nothing new there. Okay, so let's find our quartiles. First thing that we want to do is, just like finding the median, we want to get them in order from least to greatest. Okay, and then we're going to divide them into halves and then into halves again. So if we remember, once we get our data lined up in order, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. So we need to find the median. Be the number 1, 2, 3, 4, 5, 6, 7, the 8th number. Okay, the 8th number. Then you look at just the bottom half. Just the bottom half. And you find the middle. And then you look just at the top half. And then find the median of it. That's how you find quartiles. That's all there is to it. Put it in order, find the median of the bottom half, find the median of the top half. And you have just quartiled your data. Simple enough. Your StatCrunch will also tell you your quartiles quickly and easily, and there'll be Q1, Q2, and Q3. Q2 is your median, Q1 is your first quartile, Q4 is your last quartile. Now, you can always take your first and your third quartiles, okay, and if you subtract those, that's what's called your interquartile range. I'll do one of those when we do a box and whisker plot here in a second. So, but just to find the interquartile range, you just subtract the first and the third. Okay. That's that. Not worried about that. So, let's do a box and whisker plot. Okay. This is a summary. Remember the parts of a box and whisker plot. The box is the interquartile range. Let's see if I can get this. This box is the interquartile range. Okay. Each of these little lines are called the whiskers. They go from the first quartile to the minimum and from the third quartile to the maximum. So the thing about the box and whisker plot is you can see how your data is spread out quickly and easily. Notice that from the median, from the second quartile to the end, is like shorter. Like that is a lot more close together than it is in the first half. The first half of that box is a lot longer. So you can see that those data, the 25% of the data is spread out more than this 25% of the data. You can also see that this whiskers way down here, you may have an outlier. And you can see those things from a box to whisker plot. Okay. So quartiles break it into 4 equal parts, deciles break it into 10 equal parts, and percentiles break it into 100 equal parts. So if you are fortunate enough to get results on a test and find out that you're in the 99th percentile, does that mean you got a 99% on the test or that exam? No, that means that you are higher or scored higher than 99% of all the groups that took it. Okay. Now there might be 1,000 people. Okay. And it's going to be broken up evenly. In other words, there's only 1% of the entire population percentile or one group that is higher than you, which is pretty cool. They're very similar, but to find a percentile, you take the number of data entries less than that number and divide it by the total number of entries. And that's how you find your percentile. For example, say we have a data set in the second example, find the percentile that corresponds to 34,000. Recall the tuition costs are thousands of dollars, so 34,000 is the data entry, 34. Begin by ordering the data. There are 8 data entries less than 34. And the total number of data entries is 25. Therefore, 8 divided by 25 times 100 makes you in the 32nd percentile. Again, it's a pretty simple computation. Now, z-score is the one I wanted to get to. The z-score, we're going to take our value minus the mean. Now, remember this value minus the mean? What was that called? We've already talked about that one yesterday. It's the deviation. Okay. You take your deviation, divide it by your standard deviation. That'll get you your z-score. X minus mu over standard deviation. Okay. Z equals X minus. We could have Z equals X minus X bar over S. Same thing, yes? This one's just dealing with population, that one's dealing with scale. Okay. The speed of vehicles along a stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. So, what's the average speed now? Our average is 56, and our mean, or excuse me, our standard deviation is 4. Okay with that? Get that out of that information. You measure the speeds of 3 cars traveling along the stretch of highway at 62, 47, and 56 miles per hour. Find the z-score that corresponds with each speed. So we've got x equals 62, 47, and 56. Let's find those z-scores. 62 minus 56 divided by 4. That is what? 6. 6 over 4, or 3 over 2, or 1.5 would be that z-score. Okay? 47 minus 56 divided by 4. 9 divided by 4, or like negative 2 point, sorry, that's a negative 9. Negative 2.25. Yes. And 56. 56 minus 56 divided by 4. 0 divided by 4, or z-score of 0. Look at these 3 z-scores. Remember back to our empirical rule yesterday in our think about a z-score of a 1.5. Where would that belong? Z-score of a 1.5 belong about right here. I think it's highly probable that we'll have somebody that's going what 62 miles an hour in that speed zone. Yeah, that's not likely. It's within the 95%, right? Okay. How about a negative 2.25? Not very likely. Matter of fact, that guy's going really fast, right? Or really slow, excuse me, in this case. That person's going like really slow. That person could cause an accident. I mean, that's how slow they're going. I mean, it's less than 5% of the time are we going to be outside of 2 standard deviations away from the mean, right? That could cause a real problem. Do you see how once we have it into a z-score, you can compare it to the average and see if it's likely to happen or not? Yeah. And that's what your z-score does for us. And that's how we turn any value into a z-score. And you're going to do that a lot. Okay. You're going to turn values into z-scores a lot. All right, so let's compare a couple. This table shows the mean heights and standard deviations of a population of men and a population of women. Compare the z-scores for the 6-foot tall man and a 6-foot tall woman. Assume the distributions of the heights are approximately bell-shaped. Okay, so how odd is it to have a 6-foot man? How odd is it to have a 6-foot woman? That's what we're looking at here. Okay, a man's average height is 69.9 inches with a standard deviation of 3. A woman's average height is 64.3 inches with a standard deviation of 2.6. So we're going to take those values and turn them into z-scores. Okay, so remember 6 foot is 72 inches. So let's find the z-score for each. So with a man, we would take 72 minus the average divided by standard deviation and see that a 6-foot man's z-score is 0.7. That's really close to the mean, isn't it? I mean, that's within 1 standard deviation of the mean, yes? That's pretty average, isn't it? See how you can tell how close it is to the average from the z-score quickly and easily? Let's look at the woman. 72 inches minus the mean divided by 2.6 is 3.0. What are the chances that there's going to be a 6-foot woman? Not very good. Not very good. Less than 0.3%, right? Less than 0.3%. And they say men and women are different. Huh. Here's what you want to, here's the last thing. I want you to write this one down. This little chart on the bottom. I want you to write this down. Anytime you get a z-score that's between -2 and 2, that's so it's like 1.9, 7. Anytime you get a z-score that's between -2 and 2, that's normal. That's highly likely. That's 95% of our people. Okay? If you get a z-score that is from 2 to 3, positive or negative, that's what we would consider an unusual score. If you get a z-score of 2 point something or -2 point something, that's unusual. Okay? Sometimes they would say unlikely, but unusual. If you get a z-score that's over a 3, again, positive or negatively, you get a z-score that's over a 3, that's very, very unusual. Okay. Matter of fact, a lot of times if you get a z-score of 3 or higher, you want to double check your calculations and make sure you didn't make a mistake somewhere. That's how unlikely or very unusual it is. So z-scores allow us to compare apples to oranges and the likelihood of things happening, which is cool. And that's it. That's the end of chapter 2. End of chapter 2.